Welcome back to the course on design of power electronic converters. So, we were discussing diodes and we saw the VI characteristics of the diode, and we also saw the switching characteristics, and we also saw few terms which are important to be noted in data sheets. Now, let us look into some of the data sheets to understand better whatever we have discussed till now. So, this is the data sheet of your 3-phase rectifier, and this is actually a data sheet of a series of rectifier diodes. So, this what you can see here is of two sets of ratings 25 amperes and 35 amperes, and these are the pictures of the diodes, and so by this you can get an idea of the kind of pins that are used in the kind of packaging just by looking at the pictures. Then these are the primary specifications, the key specifications that are given here. IO is 25 amperes and 35 amperes, that is mentioned over here, the forward current specifications. Then since this is for a series of diodes, this VRRM, this is given as a range 50 volt to 1600 volt. And then this is packaging information and circuit configuration, that means this is a 3-phase bridge and is not just a single diode that is there. Okay. And then the manufacturers have also specified your key features of these diodes. So, that also is usually given in any of the data sheets, and many times they also write the applications for which that particular device is targeted. So, here there is a description that is provided for the data sheet for a description for your this 3-phase bridge rectifier. Now, here first of all you see these major ratings and characteristics. So, what you see here IO, and this is 25 amperes and 35 amperes for the two series 26 MT and 36 MT. And they have also given the case temperature for it, because forward current is usually specified with respect to temperature. So, case temperature is given as 70 amperes and 60 amperes over here. Then this is surge current rating IFSM, which is given, which what we have discussed before when I explained you the different notations in data sheets for diodes. So, this you can see here, this is 360 and 375 amperes, and that is given for the two frequencies 50 hertz and 60 hertz, which is much higher than this 25 amperes that is written. And what is the reason? Because this is related to surge specifications, and so that is for a short time interval, and so therefore this current ratings are going to be much higher than your regular current rating, which the diode will be withstanding again and again. And then there is a rating which is called as I square T, which is related to heating, and that means your fuse selection. Because if there is some very I mean non-repetitive surge which is coming, then what you need to do is that you have to disconnect, and so there may be a fuse that may be used. So, how do you select the fuse? For that this I square T ratings are given. So, that is what is mentioned over here. Then this VRRM is again repeated over here, and this is the junction temperature range, that is your minus 55 to plus 150 that you can see here. Then you see the electrical specifications in the data sheets. So, again you see here that these are for as this is for a series of diodes rectifier diode bridge rectifier. So, that is why you see different values. There is a whole table which is given over here. And so, maximum repetitive peak reverse voltage, how much it can be, that is provided, and IRRM is basically the leakage current. So, that can be equal to 2 milliamperes. That is what this data sheet specifies. Next, what is given over here, this maximum DC output current. So, that is IO, which we have seen before also. So, that is a forward conduction specifications that are provided over here. Then this IFSM, this also we just saw, and this is for your 50 hertz and 60 hertz. So, that is why corresponding to it half sine wave is 10 milliseconds and 8.3 milliseconds. That is what is given over here. And then what is the condition at which they perform the test for the voltage, that also is given over here, and accordingly these current ratings may vary slightly. And I square T rating for fusing, that also we just saw. So, that also for different conditions it is provided in this, and the what temperature at which manufacturer has provided these values, that also is mentioned. So, that is the TJ maximum junction temperature. Then there may be some other I square root T ratings that also may be provided. Then this is low level of threshold voltage and high level of threshold voltage, forward voltages. Okay. So, what we are telling over here is that, so this is diode voltage, diode current over here, and this is VD versus your diode current ID. So, here there is that threshold voltage, so which is VFTO, that is given over here as the low level and the high level. This also we have seen before. Okay. Then the low level forward slope resistance and high level forward slope resistance. So, here there is that slope which is your RT. So, low level and high level, two of them, your RT1 and RT2 are provided here. Then maximum forward voltage drop. So, what is the maximum forward voltage drop? So, this drop over here Vf that appears while it is forward biased and it is conducting, what could be the maximum voltage that is given. Okay, so, what you can see, this VFM, this is mentioned over here for 25 degree C, and this is 1.26 volt for this 26 MT series, and for 36 MT series this is 1.19 volt. So, that is why if you recall, I had told you that many of them have this voltage of 1.2 volt around as the forward voltage drop. Then DC reverse current maximum, that is the leakage current. So, that is given as 100 microamperes. Then there may be other specifications also that may be provided. Then you have this mechanical specifications that are given, your maximum junction and storage temperature range. So, Tj is your junction temperature and TSTG is basically your storage temperature. So, that is minus 55 to 150 degree C is what is shown. Then there is this thermal resistance junction to case, this I had mentioned you before what it is, and so that also you can see here that is specified RTHJC junction to case, it is given in Kelvin per watt. Then your thermal resistance case to sink means case to heat sink. So, that also is given over here, and then weight and other mounting torque when you put it on the, you want to put it on the PCB. So, how do you mount it, what should be the torque that has to be provided, that also is given in the data sheets. Then next are the performance curves that are provided here. So, this is maximum allowable case temperature. So, case temperature, maximum case temperature versus output current. So, what do we mean by this is that a case temperature that and how much your current can flow through, that actually has a relationship. So, what you see here is that your case temperature comes down as current rating, the total output current increases, and that is very much expected, because as current increases your heat is going to increase, and so temperatures are going to rise quickly, and so to protect the device, the amount of current that you flow through and then your temperatures that they can withstand, that will be inverse relationship will be there, and that is what you see. This comes down as the current increases, output current. Then here this is forward current versus forward voltage of the rectifier bridge that is provided over here. So, what you see is that two curves are given over here, and this 0.5 to 1 volt is what you can expect to be initial threshold voltage, because they have started from here, but you can recheck it with whatever that is given above. So, for two temperatures they have provided, and as this current increases, then how forward voltage drop increases, that is provided. That is what this performance curves is showing. Next, the graph that is shown here is total power loss versus the total output current. So, when we say total power loss, what it is this is voltage Vd, and then there is this current Id. So, Vd into Id is your power loss that will be happening, and that is Pd. So, there is a maximum that is allowed to protect the device. So, that is maximum total power loss that is provided over here, and then there is a total output current with respect to that. So, here you can see that as current increases, power loss is also increasing over here. Then your maximum total power loss versus ambient temperature. So, that you can see here that is coming down over here. It is decreasing as ambient temperature is increasing, and that is also what you expect, that as temperatures are going to increase, the amount of power dissipation that will be allowed will be decreasing. And there are several different curves over here which are provided. But these you can see that this sink to ambient thermal resistance, that is mentioned over here. So, previously we had seen this thermal resistance junction to case and case to sink. Now, what heat sink you choose, that will also have a thermal resistance, and that will be sink to ambient, and that is what the sink to ambient thermal resistances, as different thermal resistances will be used. So, then how this maximum total power loss versus ambient temperature, that graph changes, that is what is shown here. So, these are your total power loss characteristics, those graphs are given. Then next is what we see over here is your peak sine wave current, forward current versus number of equal amplitude half cycle current pulse, and this is your maximum non repetitive surge current. For that this is provided. Now, what it means is what actually I have discussed before this. So, for half sine wave, if you are going to pass this more current, then what is the usual current rating of the diode? So, this will be corresponding to 50 hertz cycle or 60 hertz cycle. So, if it is 50 hertz cycle, so this is going to be 10 milliseconds. So, then how much is this maximum current that your peak current that this device can withstand? and then for how many number of your pulses, number of equal amplitude half cycle current pulses, the numbers that are given while performing the test, that is provided over here. So, if you provide more number of pulses, so this peak half sine wave forward current, that means the surge current that it can withstand is going to reduce. Okay, that is what it is showing, and it is given for two of these frequencies, 60 hertz and 50 hertz. Then next you can see over here a similar this graph is given over here, and this graph is again peak half sine wave forward current versus pulse drain duration. It is actually pulse drain duration. So, that means you are giving a series of pulses, and there is a time duration of it. So, those what is the time duration for which it is provided, and accordingly how much is that these values could be. So, that is what is given in this data sheet. So, this is again for your non-repetitive surge current. You can see that these current values are high initially, but as this pulse train duration increases, so then that comes down. Then next what we see here is maximum allowable case temperature versus total output current. So, these are this we have seen before. So, but you have to note down that this they have given for 36 MT series. Till now whatever these ones that we had seen till now, these were all for this 26 MT series. So, the same curves they have also given for 36 MT series as well. Now, let us look into the data sheet of a Schottky diode. So, high performance Schottky rectifier of 100 amperes by Vishay Semiconductors is this data sheet that I am using to show you for a data sheet of Schottky rectifier. So, again you can see here there some features are given by the manufacturer. There is a small description also provided, and this is the picture of that Schottky rectifier. You can see here the packaging is much more different than previously what we saw for that 3-phase rectifier bridge. And these are the key specifications. Average forward current is 100 amperes. Now, you may compare it with previously it was written as IO, as compared to here it is written as IFAV, because over there it was a 3-phase rectifier, and the data sheet was for the whole 3-phase rectifier and not just for the diode. Then you have this VR, the breakdown voltage, which is 45 volt, and you can see here that this is much smaller. And why this is much smaller, this I have told you before that Schottky diodes they are usually manufactured for less than 100 volts. Above that it becomes difficult to make Schottky diodes. So, that is why here you can see that the current rating is much higher, it is about 100 amperes, but the voltage rating is lower, 45 volt. And another key thing that you can see here is the forward voltage drop, which is 0.71 volt. Now, this 0.71 volt is much lesser than previously what we saw as the 1.26 volt for the rectifier bridge. Then your leakage current over here, that is given as 320 milliamperes at 125 degree C. Maximum junction temperature allowed is 150 degree C. And then this avalanche energy that is also given over here, 40 millijoules. What is the meaning of avalanche energy, that also I have explained you before. Now, these are the major ratings and characteristics that are provided over here. So, here you can see this average voltage, average current, that is your 100 amperes, and this is at 97 degrees C case temperature. And then this VRRM is 45 volt. And what is surge current rating? That is for if you provide a pulse of 5 microsecond sine wave, then that is 4400 amperes. That is what the manufacturer is provided over here. Then a forward voltage drop, this is 0.65 volt, which is given at the temperature of 150 degrees C. Now please note that here they had provided it just 0.71 volt, whereas over here they provided it for 0.65 volt. So that all depends on what are the other conditions for which they are giving that VF. Then junction temperature range, that is also provided. Then what is this voltage rating? Your DC reverse voltage, that is the same as the working peak reverse voltage. So that is your VRWM. VR is given as 45 volt in this case. Then absolute maximum ratings are provided in this data sheet. You can see this maximum average forward current IFAV, that is given is 100 ampere. For these conditions they are providing that value. Then this non-repetitive surge current, that also you can see if only 5 microsecond sine or 3 microsecond rectangular pulse is provided, this goes as high as 4400, whereas if this is 10 millisecond sine or 6 millisecond rectangular pulse is provided, so that comes down to 830 amperes. And then avalanche energy and repetitive avalanche current, that also is given here. Then next you see this maximum forward voltage drop VFM, that is provided for two different junction temperatures and different values of current, and what is the range that you can see, and you can observe that this is much lesser than what was the range for your rectifier diode. Then reverse leakage current, that also is given for different temperatures. And then this junction capacitance, that also we had discussed before, that is mentioned over here, this is 2700 picofarad. Then series inductance, the stray inductance because of the package, that is given as 3.5 nanohenry, and this dV by dt limit, that also I had told you before is many times given in the data sheet. So that is provided here as 10,000 volt per microsecond. Then you see this mechanical specifications, basically your temperature range, your thermal resistance, junction to case and case to sink, that will be given, weight and mounting torque, those things we are provided. Then further you see this maximum forward voltage drop characteristics. You can see here from where are these voltages, forward voltage drop beginning when your current is lesser, and as the current increases how your voltage, that also forward voltage drop also increases, and it is provided for 3 different temperatures. Then this data sheet gives you this reverse current, that means basically your leakage current, that is given for different values of temperature, and how it changes as reverse voltage, how much reverse voltage you have applied, that is changing. Then how this junction capacitance, that is varying with respect to reverse voltage, it means the negative, the opposite voltage that you apply when the diode is reverse biased. Then there are some thermal graphs which are also given in the data sheet. This will not take it up now, this we will discuss later on in the course. Next you see this allowable case temperature versus your average forward current, and here you can see that case temperature decreases as forward current increases. Okay, so that is what we expect normally to happen. Then your power loss versus average forward current, and that is obviously going to increase as the amount of forward current is going to increase, the amount of loss that takes place, that also increases, that is provided over here in this graph. Then further what you see here in this data sheet, they have provided this pulse duration versus non-repetitive surge current IFSM. So, as value of pulse duration increases, the surge current that it can withstand decreases. Okay. So, in this data sheet there are some graphs that are provided which were not there in your rectifier bridge data sheet, and also you saw that when we saw the values, the different specifications that are given, that also are not exactly same as the rectifier bridge data sheet. So, it is depending on the type of the diode and the application of the diode. Some of the specifications will be given, some will not be given, and also performance curves. Some data sheet will have some curves and another data sheets will have different curves. It all depends on the type of the diode and the application. Next, I am taking this example of another diode. This is RURG 8060 F085. This is by Fairchild Semiconductor, and this voltage and current rating you can see here 80 ampere, 600 volt, ultra fast rectifier. So, that means this is a fast recovery diode. And again you see these features and applications are provided, and description is also given over here. So, these key specifications, you can see that the reverse recovery time, since this is a fast recovery diode, the reverse recovery time is provided, and that is given at this forward current 80 amperes, and low forward voltage drop, which is 1.34 volt, typical at this current rating of 80 amperes. Now, this here itself you can see that you can compare it with the Schottky diode, where it was given as 0.7 volt, whereas here this is 1.34 volt. Okay, so, this has higher voltage, forward voltage draws as compared to the Schottky diode. Then next you see these absolute maximum ratings, the peak repetitive reverse voltage, that is given as 600 volt, then working peak reverse voltage is same given, DC blocking voltage is also same. So, all three these voltage ratings are same for this diode. Then your average rectified forward current, so that is given as 80 amperes for this device, and that is for the case temperature of 25 degrees C. This is very important, because if your case temperature is going to increase, this current rating will come down. Then non-repetitive peak surge current for your 50 hertz half sine wave, so that is given as 240 amperes. Then avalanche energy and the storage temperatures and junction temperature range are also provided. Then thermal resistances, junction to case and junction to ambient, these are given. So, previously you saw the data sheet giving junction to case and case to sink, but here they have provided junction to case and junction to ambient. So, you can find out what will be the case to sink and then sink to ambient. That is something that you have to choose after that based on what heat sink that you are using. Then this is package information. This is using this package TO247. Then next you see these electrical characteristics given, IR as given as instantaneous reverse current. So, basically that is a reverse recovery current, which is very important specification. So, this you can see here that this depends on the junction temperature. Here this is given with respect to case temperature. So, this becomes 2 milliampere at 175 degrees C, and it is 250 microampere at 25 degrees C. Then instantaneous forward voltage, that also is given for two different temperatures. You can see here what you get. Then reverse recovery time is provided, your TRR, that is here you can see for different conditions, and this is also given for this di by dt rate, what the manufacturer had used. So, this is what I had told you before also. Many times in the data sheet this turn on and turn off whatever specifications they are making, they are given in terms of specified for a particular di by dt. So, that is what we see here, and then your reverse recovery time, your Ta and Tb. Ta and Tb are these two, which we had written as T4 and T5 when we discussed your switching characteristics of the diode. So, that is written over here as Ta and Tb. So, that you can use to know the softness factor of the diode, the S factor, and you can see here that this is 38 nanoseconds and 36 nanoseconds. So, it is I mean slightly less than 1, but it is close to 1. So, it is reverse recovery charge, that also is given as 130 nanocoulombs, and your avalanche energy is also provided. And then there will be test circuits and waveforms which are given by the manufacturer. Now, this is your forward characteristics that you can see here, this figure 1, forward voltage drop versus forward current. Okay, these are the thresholds, and then after that, as your current increases, the forward voltage drop also increases. Then a reverse current, that is basically your leakage current, how it changes with your what is the reverse voltage that is applied. Then here what we see is junction capacitance, how that is changing with your reverse voltage. Okay. Then your reverse recovery time, how that is changing with the di by dt. So, as you increase your di by dt, you can see here that when your temperatures are higher than your TRR, that tends to reduce. Then what we see here, reverse recovery current IRR versus your di by dt. So, di by dt increases, your reverse recovery current also is increasing. Then this is average forward current versus your case temperature. As case temperature increases, forward current that is allowed is going to decrease. Then next what you see here is reverse recovery charge QRR versus di by dt, that also you can see that as di by dt is increasing, reverse recovery charge QRR also increases. Further this is thermal response is also given, that we will discuss later on in the course when we discuss your thermal design. And then you can see here that this is actually your mechanical dimensions which are given in the data sheet. So, like this you while you are designing your converter, you first analyze the converter and you decide the key specifications that are required and what type of diode that you require, and then basically you go through different data sheets of different diodes and you pick up the one which suits your purpose. Thank you.